TOTAMUSICA's calculator focuses on specific sets, meaning exact transpositions, which makes the study of harmony and related melodies and patterns much more straightforward. Let's analyze a non-traditional scale as an example. The major scale Ad flat 6, set 826, also known as bebop major scale, or Barry Harris's diminished sixth scale, or major plus relative minor scale. When searching for tetrachord subsets of this scale, you get an initial result of 70 different tetrachords. To identify which of these tetrachords are not already part of the standard major scale, you can filter for those that include the flat 6 note. By clicking note 8 in the lock filter, the number of tetrachords is reduced to 35. These are the tetrachords unique to the scale with the added flat 6 note, as opposed to the 35 tetrachords that are diatonic to the plain major scale. Next, by applying the CSC filter, consecutive semitone constraint, set to max 1 to restrict consecutive semitones, which are often perceived as chromaticism in Western music, the number further reduces to 30. This filters out tetrachords less common in tonal harmony. See the related video on pressing scales and consecutive semitone constraint. Here are the tetrachords that calculator identified. This calculation shows not only that these tetrachords are the only ones introduced by the added flat 6 note, but also how they outnumber the well-known passing diminished 7th chord in traditional jazz harmonizations by 29 unique instances. This example uses a relatively well-known set to illustrate the calculator's functionality. However, its potential becomes even more apparent when applied to less familiar musical material. As an example, let's consider the 9/12 set, also known as Messiaen's third mode, in its prime form. And let's explore all the possible tetrachords it can produce. We instantly find that the total number of possibilities is 126. However, once the CSC filter is applied, this number reduces to 108. Upon closer examination and assuming familiarity with Fort numbers, we can immediately recognize that this specific instance of Messiaen's third mode includes the following traditional 7th chords: 3 dominant 7th chords, 3 half diminished or minor 6th chords, 3 minor 7th chords, 3 dominant 7th flat 5 chords, 6 dominant 7th sharp 5 chords, 6 major 7th chords, 6 minor, major 7th chords, and more. With some experience, it also becomes easy to identify the primary feature shared by all the tetrachords generated from this mode. But discovering these characteristics on your own can be more rewarding than learning them from external sources, such as this video. Now let's refine our results further. Imagine we need to determine which of the resulting tetrachords contain the notes C and A for compositional purposes. By applying the lock filter to include only notes 0 and 9 in integer notation, the results narrow down to 19. Examining these 19 results reveals that the dominant 7th, half diminished, minor 7th, major 7th, and minor major 7th chords are each reduced to a single instance. Not only does this method allow us to easily spot all the traditional chords, but it also enables us to explore all those less common tetrachords that do share the same defining features of being subsets of Messiaen's third mode, having no consecutive semitones, and including the notes C and A within their pitch sets.